Hello everyone, myself Aisha Supriya and I am from CSC section. Welcome to the concept video of operating systems. My topic is real-time scheduling. This is the scheduler model figure. A real-time scheduling intended to serve real-time application requests. It must be able to process data as it comes in, typically without buffering delays. Processing time requirements, including any OS delay, are measured in tens of seconds or shorter. Determines the order of real-time tasks execution. Higher priority process runs first. Numerical priority, relative priority. Real-time tasks, other tasks. Time quality. Real-time scheduling is one of the most active areas of research in computer science. In a survey of real-time scheduling algorithms, observes that the various scheduling approaches depend on whether a system performs schedulability analysis. If it does, whether it is done statically or dynamically, whether the result of the analysis itself produces a schedule or plan according to which tasks are dispatched at runtime. Real-time scheduling following some of the algorithms. Static table-driven approaches. These perform static analysis of feasible schedules of dispatching. The result of the analysis is a schedule that determines at runtime when a task must begin execution. Static priority driven primitive approaches. Again, a static analysis is performed but no schedule is drawn up. Rather, the analysis is used to assign priorities to tasks so that a traditional priority driven primitive scheduler can be used. Dynamic planning based approaches. Feasibility is determined runtime dynamically rather than offline prior to the start of execution statically. An arriving task is accepted for execution only if it is feasible to meet its time constraints. One of the results of the feasibility analysis is a schedule or plan that is used to decide when to dispatch this task. Dynamic best effort approaches. No feasibility analysis is performed. The system tries to meet all deadlines and aborts any started process whose deadline is missed. Static table driving scheduling is applicable to tasks that periodic. Input to the analysis consists of the periodic arrival time, execution time, periodic ending deadline, and relative priority of each task. The scheduler attempts to develop a schedule that enables it to meet the requirements of all periodic tasks. This is a predictable approach, but one that is inflexible because any change to any task requirements requires that the schedule be redone. Earliest deadline first or other periodic deadline techniques are typical of this category of scheduling algorithms. Static priority driven primitive scheduling makes use of the priority driven primitive scheduling mechanism common to most non-real-time multi-programming systems. In a non-real-time system, a variety of factors might be used to determine priority. For example, in a time-sharing system, the priority of a process changes depending on whether it is processor-bound or I/O-bound. In a real-time system, priority assignments is related to the time constraints associated with each task. One example of this approach is the rate monotonic algorithm. Dynamic planning based scheduling. After a task arrives, but before its execution begins, an attempt is made to create a schedule that contains the previously scheduled tasks as well as the new arrival. If the new arrival can be scheduled in such a way that its deadlines are satisfied and that no currently scheduled task misses a deadline, then the schedule is revised to accommodate the new task. Dynamic best effort scheduling is the approach used by many real-time systems that are currently commercially available. When a task arrives, the system assigns a priority based on the characteristics of the task. Some form of deadline scheduling, such as earliest deadline scheduling, is typically used. Typically, the tasks are aperiodic and so on. Static scheduling analysis is possible. With this type of scheduling, until a deadline arrives or until the task completes, we do not know where a timing constraint will be met. This is the major disadvantages of this form of scheduling. Its advantages is that it is easy to implement. Thank you.